Hello, everyone, and welcome to our webinar, Technology Trends Impacting the Future of AEC, presented by Catalyst and sponsored by Lenovo and NVIDIA. This is Serena Respini-Irwin from Catalyst, and I'll be the moderator for today's session. This webinar will discuss trends that are transforming the AEC industry, such as virtual reality, rendering in real time, and increasing mobility. We will also see how Lenovo workstation devices can help facilitate success for the AEC firms that are facing these transformations. The presentation will be recorded and made available to all registrants. You'll receive an email when that recording becomes available. The main presentation today will be followed by a Q&A session. At any time, starting now, you can submit your questions via the Q&A tab in your Big Marker chat panel. If you don't see the chat panel, please click on the blue chat button at the bottom of your window to bring it up. Now it's my pleasure to introduce Chris Rufo, who is the Worldwide Segment Lead, Architecture and Engineering for Lenovo, and Andrew Rink, who leads AEC and Manufacturing Industries Marketing Strategy for NVIDIA. Take it away, gentlemen.
Thank you very much. Chris here. I'm the segment lead for Architecture and Engineering in the Lenovo Workstation Group. I spend much of my time working with prospects and customers like you, really understanding what your needs are and helping that translate into world-class products within our Workstation Group. I'm going to hand it over to Andrew to talk a little bit about what he does at NVIDIA.
Yes, thanks, Chris. Andrew Rink here. Really great to be here with you today. So happy you could join us. I think my title's kind of explanatory there. It's a pretty long one, but yeah, I cover marketing strategy at NVIDIA for a couple of key industries. Obviously, to you on this call today, the AEC industry, architecture, engineering, construction. That's something that I'm really passionate about, and so I help our team at NVIDIA, go to market with all our AEC customers.
Thanks, Andrew. So what we're going to do over the next hour is talk to you about some of the trends that we're seeing, some of the feedback that we get from you and other industries, talk to you a little bit about some of these trends that are helping transform what's happening in AEC, show you some use cases that we're very passionate and excited about. And then towards the end, we'll spend a little bit of time talking about what workstations are and how best to configure them based on certain tasks. Then we'll open it up for Q&A. So I think over the last decade, we've seen a real shift in the industry. I think much of the industry has adopted BIM or building information modeling. But in the last few years, things have started to evolve even further. I mean, we're seeing technology and trends that are transforming the built environment in new ways. We wanted to share some of these with you today. I think the first is increasing mobility. We'll talk about how mobile workstations are playing an increasingly important role inside of AEC firms. We'll talk about how the worlds of manufacturing and construction are starting to converge and what that actually means to the built environment. There's a few others. I mean, Andrew, why don't you share your thoughts around VR and rendering?
Yeah, I mean, these are really exciting trends that are coming up, and we'll definitely double click into VR and rendering and so on. I think one thing I would mention is, I think there's some who would say that the AEC industry traditionally has not really embraced new technology all that quickly. But some of these, like VR and real-time rendering, are actually being pretty quickly adopted by companies because I think they're recognizing that the improvements these technologies bring to the workflows and the return on investment that these firms are seeing with their investment in this tech, is actually being realized. So I think that's one of the interesting things about some of these new technologies. They are being pretty quickly adopted and widely.
Thanks. And I think the last trend we'll talk about is around artificial intelligence and how that's being used in certain practices. IoT is another area that we'll kind of tap into, and there's some very exciting use cases that we want to share here. But let's kick it off with our first trend. Every time I go to a show, every time I talk to customers, every time I visit a site, I'm seeing more and more usage of mobile workstations in architecture and engineering and construction. I think what we're seeing is teams want to be more mobile. They want to reconfigure based around projects. They want to move fluidly between their desktop to the boardroom, to their clients, to their home office in some cases. And we hear that a good mobile workstation is an extension of who the architect, designer, and engineer is, and it's a valuable resource to them. So we often see when we go into a firm, a desktop set up with two mobile or two 24-inch or 27-inch monitors and a mobile workstation that the user can grab and go as they need to move from task to task.
Yeah, I think, Chris, this trend has been gathering pace, hasn't it, really? And in fact, I think probably today it's an absolute must in the workplace for most people.
Absolutely. And I think later on in the presentation, we'll talk about what makes a workstation tick, what's under the hood. And, I'll share up front, I spent a lot of my career working for one of the major CAD developers. And when I worked there, I had no idea what was under the hood of my workstation. Never thought to ask. It was just provided by IT, and I expected it to do what it needed to do. And then when I joined Lenovo a few years ago, I realized how much work goes into making a top-notch workstation, both on the desktop and on the mobile side. So we'll talk a little bit more. Absolutely.
Yeah,
so here, let's
that's good.
Go ahead.
No, I was just going to say that's a great point. I think there's a lot of people like that who, don't really think too much about it because it's doing its job. But sometimes, a little bit more can help you do a lot more, much faster.
Absolutely. So here's a use case that I'd love to talk about. We've been partnering with a firm called Deuce and Actual. They're based out of Holland. The COO is Hedvig Heisman. She's a wonderful designer and leader, and they've done some really, really interesting things with building fabrication. And in fact, they're doing it on an industrial scale. In a moment, I'll show you a short video, but let's talk about some of the things that Hedvig has been looking into. I think Deuce and Actual have been really looking at the industry from a variety of standpoints. We look at BIM and construction. If we look at what happened in Rome in 18 AD, and we look at construction today, and can we spot the difference? I think the difference is hard hats. It's the same construction techniques in a lot of cases that were employed 2,000 years ago. But the world has changed. We have increasing pollution. We have increased waste. We have lower productivity in certain building sites. We have the world growing at an extraordinary rate in terms of their building requirements and consumption, and little standardization. And I think what the folks at Actual are doing is very, very revolutionary. What they're doing is creating building products. They're fabricating building products on an industrial scale, whether it's archings, moldings, facades. I think what they're going to be able to do in the next few years is offer their customers a suite of options that can be fabricated almost like you're choosing a playlist for your iPod or your iPhone. Users will be able to select the kind of materials that they want and actually include them in their fabricated building product. It's all done through robotics. They use sustainable materials. It's a really excellent story. I'm going to show you a short video here. Hedvig describes it much more eloquently than I do. Now, just a word note here. I think for the first video, you'll have to click something that says accept to allow the video to play. So I'm just going to bring it up now.
Architecture is important for me because you basically give shape to the background of everyone's life. In construction, we really work with a lot of standardized products, but this also leads to a lot of waste because products don't fit.
40% of all the materials we take out of our planet is going into the construction industry. So it makes sense to rethink which materials do we use and how can we use less materials.
It seems that buildings are being designed to fit the materials that already exist. And we try to really flip this around, and we 3D print large-scale building products such as staircases, facades and floors on an industrial scale, so everything really fits.
We started this adventure as a project actually. At a certain moment we discovered that this was not a project anymore. That's why we founded Actual as a design-driven tech company to share the technology to really act as a platform for the building industry. We use computers, of course, throughout the whole process. Revit, for example, in the design process, you need quite a lot of computing power, but they're also used in the production lines. For that, it's important that we can rely on our workstations. So in our front-end software, we need to show our clients real-time renderings of the products, and for that we are using Lenovo workstations and NVIDIA graphic cards, which is a very powerful tool for us.
I think in the future the AEC industry will be much more about bespoke design. So our ultimate goal really would be to democratize architecture.
Our dream is to accelerate a more sustainable way of producing cities and buildings. And we cannot do that alone. We need strong ecosystem partners to grow with us and together build a brighter future.
I think that's a truly inspirational story. We've been working with them for the past few years. So we had them out to Autodesk University last year to speak. I think what's really, really interesting here is that they're doing this in a sustainable and circular manner. So the materials that are being used are sustainably sourced. The resin materials actually derived from a plant-based ecosystem. Linseed oil or linseed flax plants are used in the actual resin material itself. So it's completely renewable and recyclable 100%. Very, very exciting. So the second story that we want to talk about really shows how the worlds of manufacturing and construction are converging. Buildings, as we just saw from the actual story, are being more manufactured, which is a very interesting way to think about things, from 3D printing to 3D bricklaying, 3D concrete pouring. This story is a little bit different. React Robotics is a firm that's designed basically a dog bot that's based around open source robotics. It's designed for people in construction to be able to take and modify the robot to do task-specific sites. And you'll hear Greg talk about this in a moment, how there are many dull, dirty, and dangerous tasks on a construction site, and a robot can be programmed to perform some of them, whether it's attaching a Faro scanner to its back to scan site conditions, whether it's being programmed to replace tools, safety and maintenance. It's very emerging concept at present. And again, these guys are at the leading edge of creating these robotic tools that can be used in construction based around artificial intelligence and other technology. And this isn't like the toys we used to play with as kids, where you would drive the robot with a remote control. These are self-aware and can be programmed to do site-specific tasks. It'll know where stairs are, it'll know where objects are, know how to avoid them. So an awful lot of work has gone into this. Let me roll the video here so you guys can have a listen to Greg present in his own words.
Right now, there are many dull, dirty, and dangerous jobs that people have to perform. What if in the future they could be performed by robots? We really think it depends on the success of artificial intelligence.
What we wanted to do was find a way of bringing intelligence into the real world. So React Robotics is aiming to build a robotics body for the artificial revolution that we've all seen coming. Dogbot is about opening the way to robots that really understand the world and interact with it.
The robot has 12 axes, so 3 axes on each leg. It can walk, it can trot, go out with sensors on it of various types. So it could be 3D scanning the space, but it could also have thermal cameras and be detecting gases with spectral cameras. It's predominantly 3D printed. We're using Autodesk Fusion 360, so we can very quickly design something, test it, print a new part overnight, and retest that part. This allows us to manufacture much less components than if we use conventional methods. So we can consolidate multiple functions into single parts, and therefore it's very quick to build this robot.
Lenovo's ThinkPad P1 has been hugely helpful in our product development process. The full CAD model of the robot is actually quite big and complicated. To keep the tool fluid and responsive, you actually need quite a lot of compute power, and that's why having a powerful workstation is essential for our workflow.
It's really important that we work with partners like Lenovo. They share our vision for really taking technology out into the world. We have a very open ecosystem, and we think that the more people that have access to that ecosystem, the faster the capabilities of the robot will develop.
In terms of research, the most fascinating problem is how to create an algorithm that can learn to learn.
In making a robot that can deal with the real world, there's a huge amount of data that you need to process. In fact, one of the things we had to do in the latest generation of robots is update from CAN bus to EtherCAT, so that we have 100 megabit links to get the data from the joints back into the computer fast enough and with low enough latency. So we use Ubuntu Linux because we can use it from our embedded environments on our robot through to our workstations and our machine learning platform.
Building artificial intelligence for robots is actually extremely difficult, not because of the mathematics or the algorithms, but because of the high expectation level of the general public. To achieve human-level intelligence and human-level motor skills, we need the best possible hardware and the best possible computing power.
In our ThinkStation, we're using NVIDIA Quattro RTX GPUs with tensor cores to accelerate our machine learning, because the faster your graphics card, the faster you can train your algorithms, the faster you can iterate. It's a really exciting time to be in robotics and artificial intelligence. Things are happening every day which change what is possible, and with partners like Lenovo to help us along the way, who knows what we'll achieve.
So again, another inspirational story, and while it's not specifically an AEC story, you can see how manufacturing is playing a significant role in not only the development of tools to support construction, but providing a synergistic relationship in what those tools actually do on a construction site. In the case of Dogbot, being able to perform those dull, dirty, and dangerous tasks that don't make sense for humans to do, or don't make sense for humans to do at certain times during construction.
That is a cool video, Chris, and I think it's a good example of how AI is beginning to impact all sorts of industries, all over the world. I mean, it's been, if you like, a bit of a buzzword over the last couple of years, but I think it's really progressed to the point now where we're seeing real practical uses. So I find that very exciting.
In fact, 2 or 3 years ago, we'd walk into AEC firms and we'd ask, is anybody interested in artificial intelligence? And it would be like, no, it's not.
It's not relevant, right?
It's not relevant. And in the last year or so, things have started to change. We're seeing some larger firms hire data scientists. We're seeing some projects emerge from an R&D level that help advance what's possible in architectural design and construction. So this is one area definitely one area to watch. And we've got another example later on in the deck that actually shows a more practical use case for AI and IoT. Let's look at the next one here. We'll talk about VR, AR, and collaborative design. I think this is something that both Andrew and I are very passionate about. We've both spent a lot of our good portion of our careers actually working in the visualization space. And I think what we see now is that VR and AR more recently is changing the way architects design, make, and use what they build throughout the product life cycle. And we've got a couple of examples to talk about. I mean, Andrew, why don't you, from your perspective at NVIDIA, why don't you talk about, the requirements for VR and some of the use cases that you're seeing?
Yeah, sure. Actually, we might touch on that a little bit later. What I wanted to talk about, Chris, was Just from my own personal experience, because you mentioned that, both of us are really passionate about VR, because I think it's just such incredible technology. So in my experience, I know people who have talked about virtual reality, being around in the 1960s, and I bet some of you heard about the Sword of Damocles, right? That complicated setup where you had this massive device hanging over your neck while you were in sort of trying to get into virtual reality. And I think what's really exciting is how far it's progressed. And not so much really, in my opinion, from the 60s to, let's say, 2015. Of course, cool things are happening, maybe more on with caves, with computer-aided virtual environments or power walls, that kind of surround sort of thing. But I think, the step forward that we saw with a more of a personalized head-mounted display, that was a real thrill. I think it was 2015 when I tried out the first one, and back then our graphics were, obviously they were industry leading, of course, but there were limitations at that time, and I had that experience that probably a lot of folks had who tried it out in the early sort of Oculus phase, right? Where you were getting that lag and latency when you were moving your head, and the image wasn't keeping up. It wasn't just simply the displays simply weren't refreshing fast enough because graphics power was insufficient, and you kind of felt that touch of motion sickness. And a little bit to the point you were just making, Chris. We've come a long way since 2015. NVIDIA, I think we came up with the first VR-ready GPU with our Pascal GPU generation architecture, which I think was 2017, and by then we had kind of solved the problem of that lag or latency for the refresh, and then of course our partners in the VR ecosystem on the HMD side took advantage of this more powerful graphics to improve the resolution of the display. So we keep pushing the frontiers of what we can do with VR, which is perfect. That's exactly what we want to do, and I'm looking forward to seeing where we end up in a couple of years' time.
Excellent, thank you, Andrew. I think the use cases fall into a few buckets here. I mean, there's dozens of use cases that we've seen, but
we'll get ray tracing into VR. That's just indistinguishable from reality, right?
It will show you an example shortly too.
Yeah, but I mean, this is what right at the beginning of this webinar, I was making the point that this is one of those technologies that the AEC industry is embracing, because they are seeing that how useful it is, and they're realizing that ROI, and there are multiple use cases in this industry where it's proving its worth. Of course, a design that's probably the obvious one, but so it's extremely useful for design, but it's also proved useful when you move, for design reviews, not only for internal project teams, but also for clients, for owner developers that AEC firms work with, and that's because that immersive experience, those of you who tried it know it, right? That immersive experience, it just makes it so much more intuitive to see how the built environment will eventually appear. And the fact is, we talked to dozens, if not, dozens of customers, or actually at our annual user conference, GTC, we'll probably talk to hundreds, right? Where, most clients of working on architecture projects or helping, commissioning buildings, they're not experts in building design. So many of them, they don't find it so easy to truly understand how the space will look once it's constructed. When they're looking at 2D drawings or even 3D models on monitors. So that true scale that we get with VR really helps everyone. Design teams, architectural designers, the construction folks, everyone. But especially I find from conversations with architecture firms, those non-expert decision makers, help them understand much more intuitively what they're looking at when they're experiencing the model in life size, and they can view spaces from every angle. 360 views, walkthroughs. So all of that immersive experience in virtual reality really does help them evaluate design decisions and modifications that are being proposed. And so they're just that experience just helps them be a lot more confident when they're making decisions. Many of you have experienced the client who just simply can't make up their mind because they don't feel like, I'm just not sure, I can't really visualize it. And so, VR, this obviously speeds up decision making and reduces those design review cycles. It really helps keep projects on track. The other major area of VR adoption is for training, and training definitely benefits from virtual reality because it's allowing workers to practice virtual construction rehearsals or maintenance work in a realistic, immersive scenario, and that just is a more compelling experience that really results in effective training. There's been sort of academic studies that have been published showing how much more effective training is in VR. So it really helps with planning the construction process and the timeline when contractors can go through step-by-step installation instructions, in life-size sort of environments, and identify problem areas early on. That's also very important, so they can practice equipment placement work virtually before it's actually on the job site. So it really helps teams identify risks and potential obstacles in advance. And of course, the net result, saves time and money as well as improving safety. So it's terrific technology. The one thing that we've highlighted here is that that immersive virtual reality does require about 7 times more performance than used in PC gaming. So it's important to keep in mind you do need a powerful GPU. But like I've said probably more than once, firms are seeing the ROI, and this is leading to quick adoption. In fact, I've seen a survey by the AIA recently that indicated that 67% of large architecture firms have already integrated VR into their workflows.
That's an excellent point, Andrew. I mean, if we look at the survey of headsets in the marketplace, a few years ago, there were only a few players. Now there's an entire continuum that goes from, these are all professional level tools here, and use cases are horses for courses based on what you need to do. You've got the, Oculus and Microsoft and Vive products, but we've also seen the market change over the last couple of years, where we've seen new players integrate or introduce new technology that allows for much higher resolution experiences that are, truly photorealistic. We've got the Vario, the Xtal, the Pimax as well, are all interesting technologies. And, the important point to note here is that when you're looking at a headset, you also have to look at the workstation and the graphics card in particular that you put in the workstation to be able to drive that headset.
Yeah, I think this is some tremendous technology that's been developed here, particularly at the high end. These extreme high end HMDs, like the Xtal that you're mentioning, it's from a Czech company, VR Engineers, and that they've specifically optimized their Xtal HMD for the ultra high end Quadro RTX 8000. I mean, that's a behemoth GPU, right? Because they got 8K displays, so you want to be sure you got a lot of GPU power when you're taking advantage of that high resolution for architectural walkthroughs. So just to emphasize Chris's point, of course, there are, we do have mid-range VR ready GPUs, but if you do have the budget for this extreme high end, man, that's really an incredible experience.
And here's just an example of different resolution types. 14 to 15 ppd versus what Vario calls human eye resolution at 60 ppd. And you can see the difference here. You're actually able to read the type around the switches. This is actually a frame from an aircraft simulation project. So it's, when you're doing immersive training, immersive visualization, some of the newer headsets allow for a much more realistic, veristic experience. It's truly remarkable if you get a chance to see some of these new headsets or experience them. I highly recommend it.
Yeah, the interesting thing, sorry, Chris, I just want to make one more point. What's also interesting is, clearly you can see the difference here. And when you're actually in the virtual reality experience, it's even better than just looking at the screen here. But these high resolution displays, clearly you can see that it's enabling the user to read in VR. And so that's really useful for training where users need to identify and legibly read signs inside buildings, or discern information on virtual tools, like numbers, or on virtual equipment they're using in VR, like gauges or something that that they might be using in VR training scenarios.
Very cool. Now let's transition to another topic that's dear to us: rendering in real time. Andrew's going to talk mostly about this. I'll just kick it off and just say that, again, a lot has changed in the last couple of years. We've seen most of the ISV applications, or CAD vendors, rewrite their code to take advantage of some of the newer NVIDIA technology in the RTX product line, Quadro RTX product line. From V-Ray to Enscape to the game engines, there's new possibilities in terms of being able to actually experience real-time ray tracing really in real time.
Yeah, rendering is real time now. That's it is an amazing breakthrough. In fact, honestly, I don't think it's hyperbole to say real-time ray tracing is revolutionizing architectural visualization and design workflows. It's probably fair to say that many people may not quite have realized it just yet. And I think, so I'd like to talk a little bit about, what is the benefit of this and why, at least why so many firms are adopting this and why I think it's so important, and many people do. It's the realism that physically based rendering brings. Means that design teams can be truly confident that they're seeing how the materials and the interior lights they select combine with natural daylight and the structural design elements, and how that space will actually appear when the building is constructed. Because physically based rendering is not just a pretty picture. It's not like a photo. It's actually the ray traces. I don't think we have time to go into explaining ray tracing and all that. Probably some of you are familiar with it, right? But you'll see realistic reflections of let's say a tiled floor and the light streaming from the windows on a polished metal column, when RTX is turned on. That's the kind of realism I'm talking about. You're getting reflections off of reflections. It's not an approximation. It's not using techniques to fake how the space will look. So the huge benefit of that is, of course, you can now that it's real time with RTX, is that you can swap materials like glass. You can add a darker glass and instantly see the effect. So you can iterate quickly. You can explore more options. And so the ability of ray tracing to produce those predictable visualizations is a big help for better informed and faster decisions. And of course, again, that speeds up the design process and obviously saves time and money. It's worth noting, first of all, photorealistic rendering is already very computationally intensive, but ray tracing even more so. And that's why NVIDIA devised a new type of compute core called an RT core. I'm sure many of you are familiar with our CUDA cores, our original serial processing cores. And then we introduced tensor cores before, but now we have these RT cores, and that's hardware that's dedicated to ray tracing acceleration. And that advanced, combined with the higher number of CUDA cores in our latest GPUs, has enabled this real-time ray tracing with full global illumination. Some people say maybe 10 years ahead of when it was expected to be developed. But I would say even our mid-range Quadro RTX 4000 that you see here, it delivers the ability to instantly preview accurate predictable visualizations of 3D CAD models. And this is an affordable professional GPU. It's VR ready. So in many ways, it really is a sweet spot for architects and designers. Just to re-emphasize the point that Chris made a moment ago, there has been a proliferation of physically based rendering tools that support RTX and are actually quite easy to use. So, you've also got physically based materials libraries, which you can simply drag and drop different kinds of realistic stone and wood and glass into your model. So you don't need to create those yourselves. There are HDRI environments in these tools, so you can use that for all sorts of scene lighting. You don't need to be a lighting expert to set up environments and view your models at whatever time of day you might want to simulate, or nighttime, of course, right? And any season of the year, in the winter, things look different, with of course, right? And any location on the planet. So all that is pretty well automated with these tools. So I guess the point I just want to make for those of you who maybe don't even produce basic renders today, because you might think, the process is pretty complicated, or maybe you don't think you have enough time. You've maybe tried rendering with a CPU or something. But all this great tech now, you might want to reconsider and give high quality rendering a try now.
So let's look at a use case here from one of our customers. Oh, here, actually, Andrew.
That's right. We did want to talk about artificial intelligence as a practical use in rendering denoising. Yeah, this is definitely part of the technology trends that's impacting architectural design workflow. So, remaining in the creative flow, as many of you probably experienced, it can be difficult when the software and the hardware tools you're working with are a bit slow, and sort of forces you to wait a second or two when you want to see your design from a different angle, or view some modifications that you're making. And today, with increasing adoption of 4K displays, you simply need more compute power to refresh all those pixels when you're panning or zooming and rotating your model. Particularly, like probably most of you today, I would think we're working with dual displays. That's a lot of pixel real estate that needs refreshing. So as a further boost to rendering speed, NVIDIA invented artificial intelligence accelerated rendering denoising. Essentially, we leveraged AI to train the denoiser using tens of thousands of images, which enables it to make an intelligent prediction on what each pixel in the render should look like. So this massively diminishes the time for noiseless images. So you could quickly pan, zoom, rotate models while you're working and instantly view the render. I'm just thinking of looking at this image on it might not be very clear on your screen on this webinar, but to discern on this still image. But the render on the right has the AI denoiser enabled. And if you compare, let's say, the chairs, you can see on the left and the right the chairs, or maybe the plates between left and right. Hopefully you can make out there's plenty of noise on the left render. And both of these images have rendered the same number of frames. So that AI denoiser, it speeds up rendering by about 10 times, and it's been integrated into quite a few rendering software tools now that are widely used for architectural workflows.
Great, thank you, Andrew. And we're going to actually show you a customer example here from our friends at Neoscape. Neoscape's a boutique visualization agency that services the architecture community and creates high-end visualizations. They've been around for forever. They're based out of Boston. They do fantastic work. They've been using some of this new technology, using the Unreal Engine as a test bed to create some of these interactive visualizations. And I think to Andrew's point earlier, what's really exciting is that they can walk into a client's office with a mobile workstation, do a demonstration, get real feedback on the spot, because what they're showing, the client has confidence that it's physically accurate. So they can make a decision on materials, lighting, etc. on the spot without having to go back to the office and do a round trip with a render farm, which is a tremendous time saver. Now let's just have a look at this story here from Neoscape.
Neoscape is a full-service marketing agency for real estate. We've always been at the forefront of architectural visualization. Neoscape's true value comes from our creative input to our clients and our solution-oriented mentality. So that's why we're always looking into what is the best software, the best hardware that we can use to provide that service.
It's not enough to have to wait for everything to happen back at the office. In many cases, we just got to do the work when we're out there. When we first got access to the Lenovo P53s, it was like night and day. I was able to work as fast, if not faster, than my workstation back at the office.
I think the most exciting thing that is happening right now is real-time ray tracing. That's the thing I've had to wait for the last 20 years. Because of that, it was important for us to arm ourselves with good mobile workstations.
Well, it's quite eye-opening when you turn a process that normally would have taken hours down into seconds. The software is now doing things in real time because of these amazing advancements with hardware, and it's just amazing to be able to see what's possible now.
One of the first things that we started exploring with NVIDIA RTX technology was Unreal Engine with Epic Games. And so it was like a test bed. Let's put everything on it. Let's just bring exteriors, interiors, a max V-Ray scene that we didn't really curate for a game engine. And on top of that, do all real-time ray tracing for global illumination and reflections and refractions. The beauty of the P53 ThinkPad laptop is it is exactly the same as the workstation that we had. Same Xeon processors, same NVIDIA Quadro 5000. We can grab those live files, bring them to our client on a mobile platform that can actually show them exactly what we're working on, not a degraded version of it, not a, let me render you a tiny little thing so you get an idea of what it's gonna look like. We can actually work together.
It's so valuable to have your client next to you and making changes with you in real time. Their ideas can make their way into your workflow in an instant.
In the past, it was just raw horsepower. We had to have as many machines as we could and then just render. Today you can do all of that in one machine. If you're going to do that in one machine, it better be a good machine. The Lenovo P53 laptop is that machine for me.
That is a superb video. I think just hearing those guys talk about it, it really does help us understand the power of it, and that's outstanding work by Neoscape. I'm sure you were all picking up on all those accurate reflections, right? Yeah, this is just superb work.
Indeed, very, very inspirational. And while they're working in the Unreal Engine, which is a more sophisticated tool, this same technology is built into many of the CAD apps that we use on a day-to-day basis. So just transitioning to our last trend, what we're seeing is a greater adoption of AI and IoT workflows in architectural design, fabrication, and construction. And my favorite example here is what Dutch firm MX3D is doing in Holland. They've built the world's first 3D printed stainless steel bridge. It's going to be installed over a canal in the red light districts in Amsterdam. The bridge is done. They're just finishing up the last few details to be able to install it. It's a smart bridge. AI was used throughout the process, from initial design phase to developing some of the G code for the robots to actually print the 3D metal. But the last phase, I think, is one of the most interesting parts of it. What they've done is they've censored up the bridge itself and created an IoT nervous system. So there are, cameras, there's heat, temperature, displacement, sensors all over the bridge. So the bridge becomes aware of what's actually happening to it in real time. And a digital twin of that bridge can be created to monitor the health of the bridge in real time to ensure that it is performing to its design spec. And down the road, this information can be fed back into a broader smart city application, so the bridge can communicate with other infrastructure within the city. If traffic's too great, they could help calm the traffic, redirect people to other places. It's truly a revolutionary type of project, and we'll let the folks from MX3D tell the story a little bit, and I'll come back right afterwards to wrap up with a few comments.
In 2018, the MX3D robots accomplished an incredible feat by 3D printing a 12-meter long steel bridge, and the team decided to take it one step further. They teamed up with Lenovo and a group of renowned data scientists to develop the MX3D Smart Bridge. By applying innovative camera vision algorithms, the team teaches the bridge sensor system to understand what is happening. On the ThinkPad P53, they run the digital twin, an autonomously improving model of the bridge, allowing for the development of a data-centered design language for 3D printed structures. After the bridge is placed, the citizens of Amsterdam will gain access to the data and visit the digital twin online.
So again, another really, really interesting story. There's so much more to this story. This was a great summary, and there's further videos online that I encourage you guys to check out if you have a moment, because it covers everything from generative design to robotics to digital fabrication. They're on the leading edge of all of these things, and each of these tasks they had to overcome tremendous hurdles and challenges. Figuring out a system to actually print stainless steel, figuring out a system to be able to program the robots to do that, and then pioneering this IoT nervous system that's attached to the bridge that creates this like digital twin of the bridge itself is a very significant feat. They partnered with the Turing Institute in London and a bunch of others to be able to do this. So very, very exciting. So we're going to wrap up in a few minutes and open up for Q&A, but here's just a few additional pieces that we can talk about in terms of who Lenovo is and what our product line consists of, and some basic guidance around what to think of when you're selecting a workstation. So we're very proud that we've been the #1 PC manufacturer for 2 years running. We were the first to market with the most comprehensive RTX integration in a 15-inch mobile workstation. That's the P53. We have the world's smallest workstation, which fits in the palm of your hand and also includes an NVIDIA discrete GPU. And we're very excited about the P53 that's been featured in a couple of these videos. It's our most powerful 15-inch mobile workstation to date, with the option of putting in a Quadro RTX 4000 or 5000 discrete GPU. We're also very proud of the recent TBR study that was done that shows that we're 20% more reliable than other computer manufacturers on the market and over the first 3 years, fewer warranty repair issues. And some of the things that we do that most folks don't even realize, when we look at our mobiles, they're all mil-spec tested, 12 different mil-spec testing methods, 22 different procedures. I mean, who would have thought that your mobile workstation has been tested, with fungus growing on the motherboard to see, whether it will perform or not, tested at extreme altitudes, different temperatures. So these workstations, they're built to work in any condition. They're built to last. We actually had a customer who used our workstations as cable elevators in a snowy environment. Not what we want our workstations to be used for, but they all booted up afterwards.
It's making me feel adventurous, Chris.
So our portfolio consists of a desktop line and a mobile workstation line. And, at a high level, they range from the 330 family, which takes our i7 and i9 processors, Intel processors, and a variety of NVIDIA Quadro GPUs. The middle is the 520, which is the Xeon W processor, and again, can take up to an RTX 6000 card. And then the big machines, the 720 and 920, are dual socket scalable processors from Xeon or from Intel, and can take up to dual RTX 8000 cards in the 920. And then on the mobile side, we've talked a lot about the P53, which is our basically desktop replacement for a mobile workstation. It's our most powerful 15-inch mobile workstation ever. We also have a thin and light P1, which is a great compromise. It takes an a Quadro T2200 card, which is perfect for running Revit and most other CAD applications if you're using medium-sized data sets.
I think it's probably worth just pointing out, Chris, mobile workstation performance, and we're talking about this trend of increasing mobility, and I think it's partly been enabled by the fact that the performance of these mobile workstations from Lenovo is really catching up with the desktop, certainly on the GPU side, right? So users don't really have to sacrifice much by using a mobile workstation now.
Absolutely not. I think in closing, just general pieces of advice, whether you're choosing a desktop or a mobile workstation, the most important thing to look at if you are mainly using CAD applications is the processor. You got to get your processor right first, and typically you want the highest clock speed possible for your processor, because most CAD applications are single-threaded, which means they can only do one thing at a time. Some applications will also do multi-threaded workflows, simulation and analysis, and that's where having additional cores can be beneficial, but primarily you want the highest clock speed you can get. And then from there, you look at selecting your GPU. If you're doing general CAD work, that 2000 level card is perfect. If you need to do VR and rendering, moving up to an Quadro RTX 4000 is a great solution. And then if you're doing very, very complex visualization and rendering, the 5000, 6000, and 8000 RTX cards are great choices. Once you've locked down your card, the next step is look at your memory. You want to have enough memory to deal with your largest data sets. And for CAD these days, a bare minimum of 16 gigabytes is where to start. Most will go with 32, and then larger enterprise firms will start at 64 gigabytes. And then from there, last but not least, is looking at your storage. And the most important thing to remember now is that you want your boot drive to be an NVMe storage device. They're considerably faster than the older SSDs and spinning hard drives. They come standard in all of our workstations, 500 gigabytes or a terabyte, depending on what your needs are. Then you can offload storage to either the data center, the cloud, or a hard drive bay within your workstation for backup. And that brings us to the Q&A section, a quick survey. I mean, hopefully today we've given you an opportunity to see some news stories that you haven't seen before and give you a grounding in some of the things that you need to consider when you're purchasing a workstation. And now we'd like to open it up to you to ask us any questions you might have.
And if anyone is still trying to send in a question and you don't see the chat panel with the Q&A tab, look at the bottom of your screen for a little blue chat button to bring that window up. And if we don't get to your question in the time we have today, don't worry, we will follow up with all questions submitted. So during the presentation, You spoke to the fact that virtual reality requires 7 times the graphics power to deliver a smooth experience for the operator. So can you tell us where we are now? How far away are most AEC firms from being able to provide smooth VR experiences for their employees and customers?
Yeah, maybe I'll take that. This is Andrew. Chris, maybe I'll start off and you can add. So, well, I guess I would say we actually reached that point a couple of years ago now. I think I might have mentioned that NVIDIA has had VR-ready GPUs since our Pascal GPU architecture was introduced back in, I think it was 2017. And our GPUs keep getting more powerful, which enables advances in head-mounted display resolution. So everything about VR is getting better every year. So although it is a much more power is required from the graphics card than PC gaming. 7 times, that's a lot, right? You're refreshing dual displays in an HMD, very close to your eyes. So that requires a lot. So I would say that we've crossed that point now. AEC firms that we're working with are having fantastic immersive VR experiences, even up to like that X-Doll, that means a new HMD was only just recently announced, but with an RTX 8000, which admittedly is a behemoth of a GPU. It has 48 gigabytes of memory, and many of you remember when we had 4 gigabyte VRAM GPUs, right? So 48 is astonishing, and you can actually combine 2 RTX GPUs together with NVIDIA Virtual Link, so you can join two GPUs from the RTX 5000 and up to double, effectively you double your frame buffer. So I think even the biggest models today, you can get a nice smooth experience.
Thank you, Andrew. And also in the same world of VR, I have a question about VR and AR and collaborative design quickly becoming standard workflows. And some people recognize that, but some people don't. So the question is, how do I convince my team that they're a necessity and not just an optional add-on?
That's a very good question. It's Chris here. I'll pick it up and Andrew can chime in. I think showing the results to IT, CAD directors, management is the best way to convince people. If you're in a firm that hasn't experimented with it, finding that one intern or somebody who's just come on board who's got a little bit of gaming background, giving them a special task to do some R&D on the side. Proof of concept is probably the quickest way to get management to see what's possible. But from my experience over the last couple of years, I think we've pretty much crossed the chasm now. I think most recognize the value of VR and even AR and are working on implementation strategies within their firms.
Yeah, I agree. I think the ROI is pretty clear now, and that's why we've seen the adoption of this. And on top of that, HMDs are coming down in price. That VR-ready Quadro RTX 4000 it's an affordable professional GPU, so the price thing is becoming less of a factor. I think it might be interesting just to mention to some of you on this webinar that if you haven't tried VR yet, you might be thinking, intellectually sort of saying to yourself, yeah, it seems kind of interesting. There's a lot of good value points, but I would really encourage you, if you haven't tried it, to go to a conference, right? One of those many conferences that are out there near you, maybe, and try it out. There's tons of demos going on all the time, and once you've tried it out, you'll be like Chris and me, going, "Man, this is great."
Well, thank you both, Chris and Andrew. We are actually out of time now. And thank you to our attendees for being here today. As mentioned earlier, you will receive an email notifying you when the recording is ready. We'd like to thank our sponsors, Lenovo and NVIDIA. And we hope that everyone found this information useful. And please don't hesitate to reach out if we can answer any more questions for you. Have a great day.
Thank you. Goodbye.
Thanks a lot.